This week I didn't get to work on my project as much as I wanted to because I got sick. However, I did focus most of my attention on the current sensor. So the main thing that I discovered is that there's a minor setback that we're facing here with the problem. So right now we have this hooked up to the oscilloscope. We're measuring it at about 28 millivolts, 36 millivolts. This is just at zero. Nothing is plugged into the outlet at all. Now, if we were to plug in one light bulb, our current is reading at 0.779 amps. And in millivolts, we're looking at 190 millivolts. If we were to plug in a second light bulb, we're drawing in 1.54 amps. And our peak-to-peak is 358 millivolts. Now, the issue here is, I did the math on the calculator, is that our ACS712, it's rated at 100 millivolts for every amp. So I multiplied 100 millivolts times our current, which was 1.545 amps. It got us a change of 154 milliamps. So this should be what our amplitude is. Now, when we look on the oscilloscope, however, we're getting 356 peak to peak. Divide that by 2, it's 178 millivolts. So this is a pretty big difference. These values should be closer to each other in order for them to actually be correct. So I think my next goal right now would be to do as Dr. Amos has suggested, is to actually calculate the values of the ACS712 to see what the different values are when using different amperage. The last thing that I did was I also looked up the bistable relays that we're going to be using later on in our project. I was able to find some cheap ones. The bad thing is that they're limited to only 10 amps. However, they're cheap and they're low power usage, and they work perfectly with our product because they only require 3.3 volts to control, which is what our Teensy runs at.
So this week I worked on fixing the problem of outputting the correct average voltage for our senior design project. And the reason why we want this to be fixed is because we want to average out the voltages being read throughout 1 minute and save it to a text file. So just to show that we fixed the problem, I'm gonna start reading in voltage reading with my phone. And right now, right here it's reading 2.48, and right here it's reading like 2.41. So it's like less than a percent error. So then right now I'm reading in the voltage readings, and then when I press 2, it'll give me the average. So right now, the average says it's 2.48. And that's like the correct average value that we're supposed to get because I just kept the same voltage consistent. And the way we fixed the problem was by extracting each character that was that was saved in memory. Because when we saved our values, so for example it was 3.62, it'll be saved as 3.62 in memory, but every time we would extract it, the first value would come out as a decimal value, and that could be seen in the ASCII table. So for example, like here we have 50, and on the ASCII table, that is number 2. So what we did was as we extracted each character, for like the first place, I multiplied times 100, and then for the second value, I put multiply times 10, and then the last one I left it alone. And then to get that back into like a 3.62, I divided by 100, and this is what took care of the problem. And then the other thing I've also been working on is the RTC. So pretty much this is like the circuit diagram for the RTC, so we could start using the time into our program. So we could do features like the timer to set a time, and the user will be able to turn off their smart outlet.